All right, 13.2, define general angles. And use radian measure. All right, so these first three problems are matching problems. So I'm going to write all the problems, draw the graphs that are in the book. It's on page 862 if you don't want to draw them yourself, and then we'll go over, like, we'll match the right answer with each problem. So
What did you say was that?
862. So you might want your unit circle handy just to look at, and just in terms of helping us visualize things. So if you don't have that out, you might want to grab that. You don't necessarily have to have it, but it might help. All right, so with these problems, they give us different angle values up top, and they ask us to basically match it with the graph for the match the angle measure with the angle. So the other day we did positive, and positive goes around like this. So it goes down and around counterclockwise. Yeah. Or I guess up and around counterclockwise. So there's only one of these angles that's given to us in 3, 4, and 5 that is positive. So I need to look at my graphs down here, and I'm going to see which one is going in the positive direction. So which one would that be? C. Okay, so the way that we would look at this, let's say we weren't 100% sure on that, or we had multiple that were positive. We start here, and we know that one full time around is how many degrees? 360. We add another 90. That would put us where? 450. Add another 90. That would put us. And then this goes around. It appeared to be about 60 degrees. So what does that put us? 600 degrees. Okay, so one full time around is 360, and then we're just adding the angles around until we get to there. Okay, so 4 would be C. All right, so I have two negative ones. And so I am going to look and see what I think is happening. So basically all that's going on is, I'm going to put this unit circle up here really fast. So we start here and we start counting down and around this way, going backwards. So like for the negative 9 pi over 4, we would be negative pi over 4, negative 2 pi over 4, negative 3 pi over 4, negative 4 pi over 4, negative 5 pi over 4, negative 6 pi over 4, negative 7 pi over 4, negative 8 pi over 4, and then down here, negative 9 pi over 4. So finishing up over here in this quadrant. So which one would that be? A or B? A. Yep. So the other thing is we know that how many radians is all the way around? We know 360 degrees is all the way around. How many radians is all the way around?
2. Yeah.
What pi value is all the way around?
2 pi.
2 pi. Okay, so 8 pi over 4 would be equivalent to what? 2 pi. So I know that this has to be what? More than what? Okay, so it's more than one full time around. So this one was the only graph that went more than one full time around. So I could have also figured it out that way. So then the last one, negative 240. So basically, I would just go like negative 90, negative 180, negative 210, and then another 30 up here would be negative 240. And so that's where that would be. So 3 is going to be B. Yes.
How'd you get 5? How'd you, like, what was the, I would complete, I don't understand, like, the process.
So I start here at 0, and because it's negative, I work my way backwards. So I start counting all the ones that have a pi over 4 or the ones that reduce to pi, like a pi over 4 that reduces. So basically these and then the axis points. And so I start counting. So I go down. So this was negative pi over 4, negative 2 pi over 4, negative 3 pi over 4, negative 4 pi over 4, negative 5 pi over 4, negative 6 pi over 4, negative 7 pi over 4, negative 8 pi over 4, and then all the way back around would be negative 9 pi over 4, or like all the way around once is 2 pi, which negative 8 pi over 4, so then a little bit farther would be that. So that's how you can keep counting. So like we have like the most basic form, but you could find 27 pi over 4 if you wanted. You would just keep counting around. Now at a point I would start reducing it into sections of 2 and see how many times I actually went around so that I don't keep going around a million times having to count every single little one. But I won't give you a problem like this on your quiz or your test, like in terms of I'm not going to give you a graph and I'm not going to give you values and be like match these because, well, that's too difficult to put on like the quizzes. But this is mainly just for you to help you visualize what's happening so you get more familiar with the unit circle. And that's also why the book doesn't teach the unit circle yet. So at this point you wouldn't have known this, but if you don't know the unit circle, you have a really hard time doing these problems. So that's why I always do it first. Let's see what's next. Draw an angle with the given measure in standard position. So standard position means we start at 0 and we work our way around until whatever degrees or radians they tell us to get to. And we're going to be drawing it. So our drawing of a standard angle is going to look like what's in red. And then we usually just draw the angle down. The official angle would be what's in blue, but we draw the red little circles around to show how far around we actually go to get there. And to show which direction we're going so people know. Does that make sense? Okay.
How do you know where to start?
You always start at 0. In standard position.
On the top or the bottom?
It's positive or negative. Sorry, I was not understanding your question. All right, so 6. So the first one is going to be 110 degrees. Now, obviously, on our unit circle, we have known values, right? Is 110 degrees a known value? No, but I can figure out approximately where it is based off what I do know. So 110 degrees is positive, so I'm going to start going up and around. So I know that from here to here is 90. Okay, so I know that I need to go just 20 degrees past that. And so I'm not going to like get a little protractor out and be like, oh my goodness, is it exactly 110? I don't care. Just don't draw it like, you know, way off over here somewhere. And so I would draw something like this that shows where it's going, and then draw your actual angle up like that to show that that's where that angle is. So you have a little like guide arrow that shows the direction so that people know which way you're going. If they didn't have the problem, they could figure out approximately what angle you were trying to draw based on the information that you gave. Let's see. 450 degrees. So 450 degrees, what do I know about that?
It's gonna go around, all the way around.
Yep, I know I'm going all the way around one time. And then how many degrees past that am I going? So what's 450 minus 360? 90. So that means that my angle is going to end up on here because I go all the way around once. That's 360 degrees, and another 90 puts me back or up on that y-axis. And so my angle would actually be on the axis there. And you'll learn what we call those angles in just a minute. Let's do one more. 10, 6 pi. So what do I know about 6 pi? How many times around? Or what's one time all the way around? 2 pi. So if I go around once, I have 2 pi. If I go around again, I have, and if I go around again, I have 6 pi. So this would be, just so that you can see it, this would be 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi. So this would be just on the axis there like that. Okay, now problems like this, I could ask you to draw, okay? Because you're given information, you can draw a picture of what that angle looks like. I'm not saying I do that all the time, but you could do that. I'm just not going to give you like a matching problem. I'm going to show you actually one more that's like this. It's an odd one because otherwise you wouldn't know how to do this problem. If it was given to you 5 pi over 18. So I'm going to go ahead and draw this, but I'm going to have to do some math over to the side to show you something. So 5 pi over 18, anything that is pi over some number, that means that that's how many sections this is broken up into. So when I'm doing the pi over 2's, there's one section, two sections, like in the top, and then there's two sections in the bottom. Okay, so the pi over 6's, there's 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. Okay, so there's 6 sections. So if I have something over 18, how many sections am I going to have on the top? 18, okay? Now, you probably are like, well, how do I know what that's going to look like? We're going to look at it in terms of degrees because it's going to make it a little bit easier. How many degrees are on the top? 180. So I know that it's broken up into 18 sections and it's 180 degrees. So what might every marking be? 10 degrees. Okay. So basically this would get broken up into 9 sections, okay, in the half, and then it will have 9 more on this side. So in total, I'm going to have 18 sections. So I'm just going to try to 4, 5, 6, I don't have enough. 7, wait, 1, 2, 3, 4, 5, 6, 7, 8. I need one more, right? Okay, not like a great visualization, but just so that you can see it. And then I would have the same thing on this side, but I'm not going to try to smush them in there. Okay, so 5 pi over 18 then would be 1, 2, 3, 4, 5. So it would basically be to right there. And so then this mark here would be 5 pi over 18. Okay, so you can break it down into something smaller to be able to graph that. Now, once we do the conversions for how to convert radians to degrees, degrees to radians, all of that, it'll probably make your life a little easier when you're trying to draw the graph, just because you'll be able to think of it in terms of degrees, which with something like this makes your life easier. But anyways, I just wanted you to see what that was looking like, and how to do that one, just in case it comes up. All right, finding coterminal angles. So find one positive angle and one negative angle that are coterminal with the given angle. So when I said you're going to find out what the names of these are up here when they occur on something that I already know, 110 wasn't an angle that I already knew, and it's still within that 360, so it wouldn't have mattered. But 450 was bigger than 360, and so we said that 450 is in the same spot as 90 degrees, okay, if you look at your unit circle. 90 degrees is on this line. 450 degrees is also there. Those angles would be coterminal, okay. Over here, this would be the same as 0 pi, 2 pi, 4 pi, 6 pi, 10 pi, negative 2 pi, all those things. Those are called coterminal angles. So when we do coterminal, we're either adding or subtracting either 360 degrees or 2 pi if we're dealing with radians. So coterminal angles, we add or subtract, okay, because we need a positive angle and a negative angle. 360 degrees or 2 pi, and when we do 2 pi, it can be like 8 pi over 4 or something like that, so that we have a common denominator. So 16 is 255 degrees. So what I'm going to tell you is there are infinite amounts of angles that are coterminal with that angle. Okay, I can add 360 as many times as I want, and I can get a known angle. I can subtract 360 as many times as I want, and I can get an angle. Okay, but what I want is I want the first positive and the first negative one that you get to. Okay, I don't want you to go down and like subtract 360 like 8 times and give me that angle. I just want you to do it until you get to the one negative angle. Now, there's going to be one positive one that we're going to look at that there's going to be a couple that you could give me that would all be fine. Now, obviously, it's not wrong, but one, I don't think you want to do that much math, and two, it just makes life easier. So I'm going to add 360 to this, so 255 plus 360. So that would be 5, 11, 615. So 615 degrees. Make sure you have your little degree symbol on there if you're doing degrees. And actually, I normally stack them when I do them just to make it easier to do the math on. Subtracting 360. For that one, I usually will do the 360 and subtract the 255 and then just put a negative sign on it. So I'll set it up like this. So that would be 105, but it would be negative because of the signs are switched. So the coterminal angles with this angle, it would be 615 degrees or negative 105. So that would be the first positive and the first negative one from 255. Let's see, 18. So 18, they start us with 820 degrees. Now, you have a couple options here in terms of doing your positive one. If you want to stick to the norm and add 360, you can do that. So I'll do that one first. So 820 plus 360, and that would give you 1180. So that's one option for your positive angle. But I need to also get a negative one, okay? So if I subtract 360, 820 minus 360, then that's going to give me 460 degrees, which is still too big. It's not negative. So I would subtract 360 again. So I would take 460 minus 360, which would just be 100. But that's still positive. So I'm going to subtract 360 again. So 100 minus 360 is going to be negative 260. So any of these here, I would take as your positive answer. Okay? Those are all positive angles that are coterminal. Okay? The book, just for reference for you, uses 100 because that's a known angle, but it just says you need to give one positive coterminal and one negative coterminal, so I would take any of these. Because I know that 820 is bigger than 360, I would probably never add because I know I'm already going to have to subtract once, if not twice, when I'm doing them, just to even get down to positive, and then I'm going to have to do it again to get a negative. So this would be your negative answer over here. Any three of these would be fine as your positive answer. Okay, so you can, like I said, continue the trend of adding 360, or you can just subtract 360, and any of those positive ones are fine. Any questions on that part? All right, those are degrees. Let's look at the same thing but with radians. So 20 negative 7 pi over 6. So in this case, I'm adding or subtracting 2 pi, but I'm dealing with fractions and you can't convert these to decimals. I'm not letting you convert them to degrees. You have to do them in radians because that's what they're given to you in. So I need some way to write 2 pi in terms of something over 6. So what would that be? 12 pi over 6. So I'm going to be adding or subtracting 12 pi over 6. Now, this angle is already negative, so I need to make sure I pay attention to that sign when I am doing these. So I'm going to have negative 7 pi over 6 plus 12 pi over 6, which is going to give me 5 pi over 6. And then I will subtract 12 pi over 6 because I need to actually find a negative one. Huh? Oh. Minus 12 pi over 6. So that would be negative 19 pi over 6. And so that would be another coterminal one.
If we can, should we reduce?
I'm gonna say no, just because this way for you to visualize it, it'll make it easier.
Okay.
I won't mark it wrong if you do, but just visualizing it will be better. I'm fine with you just leaving it. And in a lot of cases, reducing is just gonna give you something that's you might have already started with at one point because you're adding 2 pi or 360. Um, $22. 20 pi over 3. Now, what do you notice about this one? Like, how many times around would this one be? Two pi. What would my factor be that I'm adding or subtracting in this case? What's something that's equivalent to 2 pi, that's something over 3? Gotta stay in radians, given to you in radians. No, like equivalent to 2 pi, that is something over 3. Yep. 6 pi over 3 is going to be equivalent to 2 pi. So I'm adding or subtracting 6 pi over 3 because that's equivalent to 2 pi. So how many times around is this going? Increments of this.
Oh.
3 times and then another partial, right? So if you wanted to, instead of having to do all the math of subtracting, because with this one I wouldn't be adding 6 pi over 3, I would just be subtracting and using one of those as my positive one. You can subtract 6 pi over 3, then you can subtract it again, then you can subtract it again, and then you can subtract it again and you'll finally be to your negative 1. But if you recognize that this is 3 times around, I can multiply this whole thing to get 18 pi over 3. Okay, so if I multiplied 6 pi over 3 by 3 and get 18 pi over 3, okay, I can then subtract 18 pi over 3 from this. So 20 pi over 3 minus 18 pi over 3 to get 2 pi over 3, and that would be a coterminal one. So that would be my positive coterminal one. And then from there, I can take that one and subtract 6 pi over 3, which is going to give me negative 4 pi over 3. And then I have my positive and my negative one. Now, if that just confused you, just subtract 6 pi over 3 a bunch of times. But just trying to make your life a little easier if you recognize that. As you get more familiar with them, you'll be able to do that. Any questions on that one? That one's obviously we did a little differently. Now, if you had added 6 pi over 3, again, I would still take it because that would still be like the first positive one in terms of adding. So if you did 26 pi over 3, that would be fine also, but or any of the ones in between. Yeah.
You subtracted the second time by 18 pi over 3?
You can, but that would be like, well, I mean, it would still be coterminal. That would be fine. It just would have given you one that was farther negative than you needed to go. But yeah, I would take it if you did that. That's fine. All right, the last thing we're going to do for today, I think, is conversions. And then on Wednesday, we'll pick up this section from there. So conversions from, it says go from degrees to radians or radians to degrees. So whichever one you start with, obviously you're going to the other. For some reason, people get confused about that. They're like, how do I know which one? It doesn't specify. It's like whatever you start with, you're doing the other. So 24. 315 degrees. And I want to go to radians. So the conversion factor that you should have in your notes is pi over 180 or 180 over pi, depending on which thing you're dealing with. So if I'm going from degrees to radians, then it's going to be pi over 180. If I'm going from radians to degrees, it is going to be 180 over pi, because my goal is to get my units, quote unquote, to cancel. So in this problem, I have degrees, so I'm trying to get radians, so I'm going to be converting by pi over 180. Now, the temptation for people is to plug this in your calculator. Do not do that. Okay, radians are written as fractions. Okay, and the pi stays. You're not actually multiplying the pi through. All we're doing is reducing 315 and 180. Okay, so your final answer, which is what cues you in that it is radians, is that there will be a pi in it. So it is going to be something pi over something. So I'm looking for something I can take out of both of these numbers to try to reduce it down to something that I know. So any idea what I might be able to take out of that to reduce it?
30. Or 3, 8,
15. Okay, I would try 15 because it's bigger. So if at this point, if you need to like get your calculator to like reduce it, that's fine, but don't just plug it in. So 315 divided by 15 is 21, so that would be 21 pi over 180 divided by 15 is 12. Is that right? Oh, we can still reduce it. What else can I take out? 3, so that's going to be 7 pi over 4. So in these ones we do reduce. Okay, reduce all the way. So that is the conversion from degrees to radians. Now, if you go on your unit circle, because that was a known value, 315 is a known value, all you would have to do is look and see that it is 7 pi over 4. But they won't always be known values, so you won't have to do anything. But let's see, 26. 500 degrees. Again, I started with degrees, so pi over 180. Now, anytime I have something that ends in zeros, a lot of times people forget this, but you can just mark off a 0 at the end. Okay, we reduced it by 10. So then 50 and 18, is there anything that I can take out of those? 2. So 25 pi over 9, and that can't be reduced any farther, so that one would be done.
or 18.
Let's see, 28. All right, these ones are given to you as radian, so negative pi over 4. Now, I'm going to show you this, and you need to make sure you pay attention to this when I tell you. Okay, a lot of people, don't write this, tend to do this. And then they end up getting the wrong answer. Okay? What you need to do when you have a fraction of radians like this is you need to do it like this. Okay? Write it as a fraction. Because now what's going to happen is pi's cancel. Four goes into 180. 45 times. So this is going to be negative 45 degrees. Okay, and don't forget the negative sign on there. If it's negative initially, it has to be negative in the end because we're just doing a conversion. Uh, 30, 14 pi over 15. So again, 14 pi goes on the top, 15 on the bottom. And then we do 180 over pi. And if you ever forget which conversion factor you're supposed to be using, the units and stuff have to cancel. So if you start with radians, you've got to be left with degrees. So that means that the pi's have to cancel. You can't have a pi left in a degree value. Okay, so pi's cancel. 15 goes into 180 12 times. So then I'm going to have 14 times 12 left over, which is 168. So 168 degrees would be that conversion. All right, since we still have a few minutes and tomorrow's just going to be a work day, I'm going to do one more thing with you. I am skipping one part of this section that we'll come back to on Wednesday, but for this part, these problems say evaluate the trig function using a calculator if necessary, okay? That means if it's not a known value, okay? Any of these that are known values, meaning anything off this unit circle, so any increments of pi over 6, pi over 4, pi over 3, pi over 2, or just increments of pi, you shouldn't be doing. But if it was like something pi over 18, you can plug that in your calculator, okay? Anything like that. So, first one is going to be 40, the sine of pi over 4. So what did we say on Friday that the sine values are on your unit circle? Are they the x or the y values? Y. So sine is the y value. So the sine of pi over 4. So I get out my handy dandy unit circle. Once you're familiar with it, you won't really have to do this, but I go up to pi over 4, find the y value, and so the sine of pi over 4 is going to be root 2 over 2. And so all you have to write is root 2 over 2. If you give me that decimal, the 0.707, I'm going to say, wrong. It's a known value because that's a value that you should know, okay? Or you'll have your unit circle in front of you to use for that. And while I'm thinking about it, on the quiz next week on 3.1 to 3 or 13.1 to 13.3, what I will do is, because you have a unit circle as extra credit that you can fill out, when you bring it to me, I will grade them right away for the extra credit, but in the meantime, I will hand you a unit circle that I already have filled out. I have like a classroom set of unit circles that you'll be able to use so that you're not like delayed and waiting for me to get through your unit circle, basically. So you'll have one like to use once you filled that one out. So if you get there and you're like, I don't know the unit circle whatsoever, which you should because you'll have already had 2 quizzes on it by then. If you for some reason just forget it or decide I don't care about the extra credit, you can just come up and hand me a blank unit circle and I'll hand you one of these and you just won't get any extra credit, basically. So, all right, 42. Secant of pi over 9. Now, do we know how to find secant?
Yes.
Okay, secant is what?
Something opposite.
Yeah, opposite of which one?
Sine.
No.
Cos.
Cosine. Okay, secant is opposite of cosine. So,
Is that probably-
if this was a known angle, okay, meaning like, let's just say it was the secant of pi over 4, then I would be going to the cosine value of pi over 4 and doing 1 over that value, okay? And that's how I would find that. But in this case, pi over 9 is not a known value, okay? It's not something we know off the unit circle, so I'm going to put it in my calculator as 1 over the cosine of pi over 9. Now, before you do that, I'm going to teach you something very important about your calculator. Your calculator has 2 modes. The other day when what we were doing, I told you to hit mode, and I said to check and make sure you were in degree mode. Okay? Now, radian mode. So it is very critical you pay attention to what mode you're in, or your answers will be wrong, and you're going to be really irritated because that's going to be the only reason your answers are wrong is because you forgot to change modes. Okay, so I need radian mode. So what you do is hit mode on your calculator. You're going to arrow down. I need radian to be selected. And then you just hit second in the mode button, and that quits and gets you out of that. Then you're going to do 1 divided by cosine of, the pi is over the little caret button, in case you aren't familiar with that. So pi divided by 9, close up that parentheses. And so that's going to end up being 1.06. We'll just do 2 decimal places for anything that needs to be a decimal. So this one would be equal to 1.06. Let's see. 44, cosine of pi over 6. So cosine are what values?
Adjacent over
X values. So on your unit circle, find the cosine of pi over 6 and tell me what it is.
Hey, sometimes I'm right, so.
What is the cosine of pi over 6 from your unit circle? So what is the x value at pi over 6?
3 over 2.
Root 3 over 2. And that's how you would give the answer. All right, last one, 46. Cosecant of 4 pi over 15. So, is this a known value? No. All right, cosecant is related to what? Sine. So, this one, when we put it in our calculator, you saw it to be in radian mode, but you've already converted your calculator to that, so you don't have to worry about doing anything. You're going to put this in as 1 over the sine of 4 pi over 15. So we would have 1 divided by sine of 4 pi divided by 15. And then we'll round to 2 decimal places, so that's going to be 1.35 for that one. Just gonna slide it back here. All right, now, eventually, not yet, but we're going to get to problems like the cotangent of pi over 6. Okay, and that is a known value, even though it may be not directly known to you. We don't have cotangent values written on our unit circle. We could if we wanted to, but that just seems excessive to write all of that on there. All we would do is we would take the inverse of the tangent value at pi over 6, and we would do that. But this chapter or this section doesn't have us doing that yet. That comes later, so you don't need to worry about that at this point, but just know that that will be coming later on. So anything in here is either going to be a known value that you already have written, or you're going to be typing it in your calculator to find it. Excuse me. So problems up to this point and what you'll be working on tomorrow in class. Going to be, let's see, 7, 13, 15, 17, 19, 21, which 21's gonna be a little bit of a harder one just because it's a pi over 9. And then 25, 27, 29. And then 39, 41, 43, and 45. So what you're going to notice is obviously that's a lot more problems, and we're not even done with the section than you normally have. However, most of these ones are pretty like semi-fast problems. But with trig, it's more important that you get a lot of practice because obviously it's your first time going through this stuff. So we will often have more problems, but we spend more days on these sections, so you'll have more time in class to get them done if you use your time wisely.
We're working on this tomorrow, but we're working on this like homework.
It won't be due until technically Friday because Wednesday we'll be finishing up this section. There's not a lot left in this section that we have to do, just a few more problems, about 4 or 5 more problems, and I'll be adding a little bit, so you probably will have a decent amount of time on Wednesday. But so I would say like you don't necessarily have to do it tonight, but it'll be due Friday, basically, is what I'm telling you.